actually give out lesson number 8, I actually want to go backwards to go forwards. Okay? No, it's hooked up. There's 2 different variations. We're going to go backwards before we go forwards because I kind of want to get it fresh in your head that this means multiplication, right? But I also want you to realize that it's repeated addition. This tells you the number that's going to get repeated. And what does the number outside the parentheses tell you? How many times to repeat it. So this is equivalent to what? This 3 times 8 is equivalent to what as repeated addition? Marcus.
8, 6, 6.
Correct. Okay. Okay with that? Yeah, you could write this. It's like a little warm-up intro, lesson 8. That's fine. Then, when you get caught up, do 2 times 6 as repeated addition. Right, don't evaluate it, expand it. 2 times 6 is what? As the same as repeated addition. Fine. Not 6 times 6. 6 plus 6. Okay? I don't want you to get it confused with this, guys. This is repeated multiplication. 6 to the 2nd power is what times what? Right. See the difference?
Yeah.
Okay. One more repeated addition. Write this out as repeated addition. Get it, Joe. 6 plus 6 repeats 5 times. Make a little note. This is how many times it repeats. This is the number that repeats. Just so you remember. However, we don't call it base though. Not like base exponent. Well, I will scroll this up here in 1 minute. See this. Okay, got it? Got one more for you. You're okay with the numeric expression. I'm going to give you an algebraic one. What about, I'll even put it in parentheses, 4 times A or 4A is what? As repeated addition. Oh, yeah. You got it. By the way, how would I tell or how can I test that this 4A is the same as A plus A plus A plus A? Who remembers? So, we can substitute A equals 2 plus 4 times 2. Just do it mentally. 8. 2 plus 2 plus 2 plus 2 is
8.
And it works. Okay? Okay with this? Because now you're ready for lesson 8. We went backwards before we go forward, but now we go forwards to go forwards. What is this? Like I said, I'm going to start you out very, very elementary. It's just to kind of get it into your head. Once again, that multiplication is repeated addition. The difference now being from what we just did in the intro is you have something like 20 plus 30 in parentheses. Okay? You still want to kind of follow the same pattern though. The number outside the parentheses tells you how many times to repeat the term or terms inside the parentheses. Okay? We can also model this, and you can kind of think of this as this tells you, number 2, in this case, how many sets there are of whatever's inside the parentheses. Okay? Think of sets of 20 plus 30. Well, how many sets are there of 20 plus 30? Then there's 2. Okay? Or, like we did in the intro, this tells you how many times to repeat in addition whatever's inside. So you have 2 sets of, here's a 20 plus 30, but you have another set of 20 plus 30. Understand that?
Yeah.
Now you just combine like terms. Well, they're all numerical. What's 20 plus 30 plus 20 plus 30? 100. Okay? So basically, again, he's kind of driving home the idea that this 2 represents how many times to add whatever's inside the parentheses. I'm going to be using the terminology sets of for whatever represents outside. Okay? Sets of. Now, we can take this a step further and use we can distributive property. Sort of, kind of.
Yeah.
How many sets are there of this 20 plus 30? 2. What I can do is do it this way as well. I'm going to keep my 20s together and keep my 30s together. Kind of always make columns. 20 plus 20 is, I'm going to write that on the line. 30 plus 30 is. Now I can still combine that further, but I'm not. All I did was distribute or redistribute. That's what distributive property is. Redistribute. You're kind of shuffling numbers around. I took my 2 and said, oh, okay, there's 2 sets of 20 to make my 40, and 2 sets of 30 to make my 60. Okay, or I did 2 times 20 is 40. 2 times 30 is 60. The only reason why I'm not going to combine this is as you'll see when we do variables, you can't combine variables that are different letters. It's eventually going to move to that. The warm-up is just dealing with numbers. So all I want you to do is take the number outside. There's 6 sets of 8. 6 groups of 8 makes how much total? Come on, we did this in words to math. 6 groups of 8. Multiply it. What do you get? 48. I'm going to take that same 6 and say, okay, 6 sets of 5 makes how much? 30. And again, I could combine this, but I'm not. Because eventually, when we get to this, you can't combine your A's and B's. But we can still apply the distributive property. Alright, now I've got 3 numbers inside. 12 sets of 3 is 36. 12 sets of 5. Make little arrows. I'd like you to do that as well, because it'll keep and remind you, because that's the pattern or formula or method that you can use for every one of these. 12 sets of 5 is how much? 60. And then, it's getting busy here, but 12 sets of 10. 12 sets of 12 would be 144, not 12 is 10. 120. Do number 4 all by yourself and pull you up. Check choice. How many of you have 30 plus 30? So approximately 9.5 minutes in, if you listen to the block, you'll hear a very disruptive noise in the middle of the block. Hopefully it still works. And now we don't have numbers inside the parentheses, but we have algebraic variables inside the parentheses. But you can apply the same principles. What's 2 sets of A? What? No. You're not multiplying A times itself. Correct. 2A. What about two sets of B? We're going to model it here in a minute, too. Go backwards again. I know. Can we combine 2A plus 2B? We cannot. They're different variables. All right. Here's kind of a visual model. What?
Can you do 4AB?
You can. Because remember, this is 2 times A plus 2 times B.
Oh, okay.
They're separate terms you can't do. If they were all multiplication, you could. But you can't if they're separate. All right, so we're going to go backwards again. Kind of model it, make it visual. Okay. First, we'll kind of go back to tape diagrams. All right. A model to show A plus A. Make a box and write the letter A inside. Remember I was kind of doing index cards with you, and when we were doing combining like terms, remember there's a piece of paper or an index card with the letter A on it? We're going to kind of go back to that idea. And we can model the plus B by putting another piece of paper, index card, or tape segment with the letter B on it. How many sets are there? 2 there. And now create those 2 sets. You have A plus B. And then you have another A plus B. Like this. And then what I'm going to do is I'm going to put a column in the middle. Because I've lined up my like terms. I can add my A's. I can add my B's. I just can't add them together. How many A's do I have? Plus, that doesn't change because we got that down the middle here. Plus how many B's? So therefore, an equivalent expression for 2 AB is 2A plus 2B. Okay? Everybody okay with that so far? Any questions? We can do the same thing. We can prove that they're equivalent by using substitution, which is the next stage. But before I do that, let me reintroduce expanded form and factored form. When you created your 2A plus 2B, you have used, or you have taken what we did in the previous example and you've expanded it, utilizing the 2 in each term. That's called expanded form. Factored form is when you factor out these 2. It's kind of like working backwards. We're going to do that as well. When you place that 2 on the outside and go back to this is called factored form. So this is factored form, and this is expanded form. We'll practice it with our examples. Just get it. You'll have to do it in exercise 2. I think on page 5. Okay, now with number 6, we're going to prove that this is equivalent to this. Give me something to substitute in for A and B. And let's avoid 1, but keep it small. Alright. Alright, let's go with A is 2. I'll put it right above it. And B is 3, you said? Okay, great. Oh, they gave it to you here? Ah, the heck with it. Let's go with Kurt. I didn't read that, but that's fine. 3 and 4. It would work with 3 and 4 also. Okay, substitute in 2 plus 3. Now it's PEMDAS when you first. What do you get? And remember, it's 2 groups of 5, which makes I put it back in when I have to multiply that. 2 times 5, I do. I could put it in parentheses if I wanted to. I could. So parentheses is not the same thing. Okay. A was how much? Changed it in the example. Yes. 2. Oops. And B was kind of do this in the same step because it's both multiplication. It's 2 times 2. 2 times 3. 4 plus 6. They are good. They are good. Okay, a little bit more advanced. Example 2. First of all, is this factored form or is this expanded form? Jeanette. Yeah, if it helps you to remember when you see parentheses, most likely you are in factored form. What's inside the parentheses? Luke. We're going to model it by making a box for 3x and a box for 4y. How many groups are there of that? Look outside the parentheses because that'll tell you. Go. Okay, so let's make another set of 3x plus 4y. Again, noting to you guys that when you do this, keep all of your x's lined up nice. Keep all of your y's lined up nice. Make a column. You're going to combine like terms. What do you get? 3x plus 3x.
6x.
Hard, man.
Can I answer the phone?
No, I got it. Okay, we have our 6x. What about 4y plus 4y?
8.
Don't call out, though. Something on this side, dude? Buzz? 8y. See why it was kind of important to spend as much time as we did on combining like terms? It's repeat throughout lessons 8 and even into lesson 9 as well. Okay, I think what I want to do is stop there because example 3 is where I think I'm going to ask you to go on to your receipt paper. That's it. So we'll stop. Alright, first thing with this page, guys, this is not negative. So get rid of this little dash here so it doesn't confuse you. We're not going to need to make models for everything that we use the distributed property for. We can simply just apply the method that I showed you. 2 sets of 3x becomes what? In other words, 2 times 3x becomes what? And we can do that and write it straight, go right straight from distributed property right to expanded form without having to model it, as long as you can see why it works. What about 2 sets of 4y, or 2 times 4y? 8y. And let's prove to see that it will work. What was our factored form again? Be familiar with it. Which of these two is factored form? You got it. You can say it simply as that. Go in parentheses. All right. Very good. Yeah, I'm gonna. Don't call out. I'll call on if you have hand raised. So expanded that becomes 6x plus 8y. Now we will stick to the examples. 2 is going to be replaced for x, and 3 will be subbed in for y. So let's do that. I don't want to do parentheses within parentheses, so I will use the dot. Did I do that right? For this, I can use the parentheses. Alright, can you do 3 times 2 times 4 times 3 in your head?
Yes.
Don't add them.
36.
as I substitute 3 for what? Where?
72.
I got you. Correct.
I got 72.
3 times 4 times 3 times 2 times 4 times 3. The other way you could do it too is, I think it's easy, but 3 times 2 is,
Yeah.
and then 4 times 3 is, it's 12 times 6. Yeah, well, that's why it's commutative. 72. And then don't forget you have the 2 outside, so 2 times 72. That's 144. Circle it. Alright, ready? 6 times 2. We made a mistake somewhere. Oh, we did. Look what we did.
Yeah, don't you have to add?
Yeah, we made a mistake. Go back.
It's 18.
This is exactly, this is great. This is why we check it, right? See if the numbers are not the same. Something went wrong. Everybody see what I did? It's not 3 times 2 times 4 times 3. It's 3 times 2 plus 4 times 3. So I have the advantage of being able to erase. You're able to cross out.
30.
3 times 2 is,
Alex was right.
it was 6 plus what's 4 times 3.
12.
All right, now we're back on track. 6 plus 12 is 18, like Alex said. And then 2 times 18 is? All right, let's remember that number. 8 times 3. Great. And then 12 plus 24. It works. Okay, now you got to go into your list. Remember that, guys. This 5a is called a term. 5y is a term. What form is 5a plus 5y? What form is that in? So it is. Everybody agree? We are in expanded form right now. Very good. So as you can see, it differs from the first 2 examples in that we're going to kind of work backwards. I give it to you in expanded form, and we've got to change it into factor form. So we're going to look at each term. 5a and 5y, look for things that each term have in common. Because there's a number that you can factor out of each term. And then you can kind of work backwards to see if it's going to work when you go from factor form back into expanded. What do you say? Does everybody see a 5? As soon as you see it, put it outside the parentheses. First put a 5 there. Then when we rewrite it, we now know it's going to be 5 outside the parentheses. And here's what you can kind of do when I say work backwards. You kind of say to yourself, 5 times what makes 5a? 5 times what makes 5a? Please. And we need the 1. We don't need the 1 as a coefficient, so we can just write the letter. Does everybody agree? 5 groups of A, or 5 times A is 5A. Plus, now that you see the pattern, obviously the second term is, you don't need the coefficient. This is now factor form. Okay? All right with it? I'm going to give you one more example for you to do on your own. All right, try this. Oh, I don't want yx. Yn. 9yn plus 9yn. Don't let the fact that there's 2 different variables throw you off. What do you see that's in both that you can take out? Actually, stop for a minute. Erase. This here is actually example number 5 because they're both the same thing. I don't want to do that yet. Watch what I will do. Erasing. Cross it out. I'll keep that same 9, but watch what I'm going to do. I'll do 9 y n 2 plus 9. I'm going to treat 2 different variables. RS. I don't want to go identical terms here. Alright, so what do you see in both terms? Man. Okay, we can factor out the 9. That automatically goes outside the parentheses. And I can take it a step further. I can put plus in the middle because I know I'm going to need it. And then work backwards. 9 times what makes 9yn? Hannah. Just yn. Very good. 9 times what makes 9rs? Fun. Yep. Now we can go back to the booklet again. Factoring out the GCF. For example 3, which we're going to change to example 4. Cross out 3, make this 4. No. Maybe for today, we'll see. You're going to have to modify your homework for a little bit of time. That's okay, though. Okay, so now we have 6a plus 3b. First of all, what form is that in? Expanded or factored? Expanded, right? No parentheses, it's expanded. The difference being, though, is the coefficients are different. First time we've seen that. We can still factor out a number from 6 and 3. And the way we do that, we have to go back and find the GCF. What is the greatest number that goes into both 3 and 6? That's what GCF is. Andrew. 3. That's our GCF. We're going to factor that GCF out of each term. So once I have that 3 is outside my parentheses. And then you're right back to what we did in example 3. 3 times what makes 6a? 3 times what makes 6a? Luke.
What?
Correct. Everybody see that?
Yeah.
Plus 3 times what makes 3b? 3x. Just b. Check to make sure it works. Work backwards. 3 times 2a is what, everybody? 6a. 3 times b is 3b. And then you know you've done it correctly when you take a look at the coefficients 2, and remember this is an indivisible 1. Okay, if you have a 2 and a 1 there, there should be no other GCF between those two numbers other than itself, or 1. Go backwards for a minute. And you agree this is really 1 big. Okay. You know that you have factored out the GCF accurately. If you look at the coefficients 2 and 1, the GCF of those two numbers should be no other number other than 1. Right? There's no number than 1 that goes into both 2 and 1. Okay? Alright? Don't write this. I'll kind of show you what I kind of mean by that. Don't write this. What if I did this? 8a and plus 12b. Watch what I'm going to do, see if you can find a mistake. What's the mistake that I just made? Cat, do you see it? Oh, you're right. I actually made a mistake on top of the mistake. What if I did this? Oh, wait. Go back a minute. I meant to do this. First of all, is it accurate? Will it work? Is 2 times 4a 8a? Is 2 times 6b 12b? However, there's an issue. Kind of the point I was trying to prove the first time I did this. What's the problem with this? What? Right, 2 is not the greatest common factor. How do I know? Because I can look at my 4 and my 6. There's a number other than 1 that will go into both 4 and 6, which is another 2. What should be my GCF? 4. If I did everything accurately, then you get, what do you wind up with inside? 3 and I did that on purpose. I want to see if you can. 2a plus 3b. Okay? Are you okay with that? All right, I got one more for you. Go back to your loose leaf paper. I'm trying to give you all of the examples that you're going to see in the exercises. Because I remember last year, they give you curveballs along the way, and we didn't cover it in the examples. So it's got to be kind of rewritten. This way now you'll have an example to look back on for 4 or 5. A little bit of a leap, but manageable. I'll talk you through it. I'm going to go right back to the question I asked you before. Is do you see something in each term that's common? Start with the numbers, 7 and 9.
7.
Is there a GCF between 7 and 9? There isn't. You can't factor out anything other than a 1. If you do that, you're going to wind up right back to where you started with a 1 outside, and you're right back to 7a and 9, and plus 9, 7a and 9a. You see a variable that's common in both. What is the variable? Factor it out. Remember, I told you, once you see it, put it outside the parentheses. Everybody get what I just did? Once you see it, take it out, put it outside. And then right back to what you did with numbers. A times what makes 7a? Just 7. Plus. Now you want to see something neat? Ready?
Sure.
Add this. What do you get? What's a times 16? 16a, right? Combine like terms. Wind up with 16a again. Works.
Great.
Okay? I got one more for you.
No.
Sample 6.
Stop. Do homework.
Then you got everything, but then you'll be happy because your homework's going to be modified.
Oh, that's good. That's good.
No, they'll be homework.
What?
Sample 6.
I have to go to my grandma's.
Here it comes. You gotta, tell you what, I'm going to put it all together. If you can do this on your own, I would be impressed. No, I can't do that. That I can't do. Here we go.
Give us more. I don't know.
I'd like you to write 3n plus 15n. All right, so I want to see if you can do it first without my guidance. I'll give you like a 30-second window here, and then I'll see what you come up with. Right now, you are in expanded form. What I wanted you to do is put it into factored form. And if I call on you, I want you to tell me what you put outside the parentheses, and then tell me what you put inside the parentheses. Marks, you got first crack. What did you put outside? And what's inside? Sort of. Jack, what do you got?
I got 3 outside.
3 outside, and what's inside?
5.
5n plus n. So what do you got?
I got it. 3 outside. Yeah. 1 inside.
That's it. He's got it. See, take a look. Do you agree you can factor out a 3? Or is the GCF of 3 and 15 3?
I got that.
Yes or no?
Yeah.
Okay, put that outside. But there's also a variable that's common in each term also. The letter, you can factor that out as well. Ready? 3n times what makes 3n? Just the number 1. Plus 3n plus what makes 15n? Just 5. Not 5n, because that would be 5n, that would be 15n squared. Just 5. Now watch, ready? 1 plus 5. 3n times 6. 18n. Find like terms, what do you get? 18n. Alright, let me tell you what you guys are going to do. This is going to be your homework, but you're going to start it in class, alright? I want you to make good use of your time. You have about 12 minutes.
Pages. Or page.
You guys are going to do pages 5 and 6. Okay? You may group up.